Aloha and welcome. In this lesson, we're going to be talking about serial reading and writing using the UART. And let's go ahead and dive in here. So the equipment that we're going to be using is quite simple this time. We're just going to use our handy dandy Pico W, our USB, our micro USB connector, our breadboard, and 2 jumpers. So the way this is going to look is this. We're just going to be taking pin 0, connecting it to pin 9, pin 1, connecting it to pin 8. Remember that when we're dealing with our UARTs, 0 is going to be the transmitter. It's transmitting down here to 9, which is the input for the other one. And we're going to have the receiver receiving the output from pin 8. So we're going to it's a very simple process. We're going to set up a program. Actually, there's a program already out there. I believe this is incorrect, what they're giving us here, but look into 0.82 for the serial read and write. You're going to find that the name of what you're looking for is serial read and write USART 0 to USART 1. And what do they say here? They say USART 1 to USART, UART 1 to UART 0. And it's very confusing what they're doing here because UART and USART are not synonymous, but they're kind of using it that way. What they've implemented is UARTs, and that's what this is calling for here. But inside the code, if you look at the code, they're calling it my USART. So it's a little bit wonky what they're doing here, but I'd like to explain what they're doing. The UART is it's a module that we can load and get some information on. Actually, the information was in our previous lessons ending. It'll give you a little bit of information on what you can do. You can set up your ID, your baud rate, your bits. Baud rate is essentially the number of bits per second. Your bits, parity, what you're going to be, which pins you're going to be transmitting and or receiving and transmitting on, your stop and your timeout as well. So yeah, so all that is here. So when we get down to the code part, understanding it isn't that difficult. So when we look at it for UART, hold on, here we go. Okay, so it says my USART 0. Just ignore that part. They're creating a UART. It's going to be ID 0. It's going to have baud rate of 9600. It's going to be 8 bits long. It's going to transmit on pin 0. It's going to receive on pin 1. And the timeout is going to be 10 milliseconds. So then UART 1, again, we're going to have baud rate 9600. They have to match up in order to be synced. Then it's also going to be 8 bits transmitting on 8 and receiving on 9, which is what we looked at in our pins earlier. So I have in this graphic above, when you can see my breadboard here, I show essentially the pins in the same holes that they talk about there. So that's just for illustration. But there's nothing that our breadboard and Pico is going to do there. It's just kind of eye candy in this. So anyways, getting down to the code, we're setting up an infinite loop here, and we're going to say we're going to receive some information in bytes. It's going to be RX data. So we've got bytes that are coming in here. So we're going to say input CNT equals string of input myUSART 1. So what we're going to do here is it's going to ask us at the command line for something to transmit. We'll say hello world, and then that will come in. It'll turn it into a string, and so input CNT will be a string at this point. So then we're going to call on my USART 1, and we're going to write it to that. So we're going to write it here. So it's going to transmit it on 8, and it's going to go to pin 1. So then after it does that, we're sleeping 1/10 of a second. This is a very curious thing. Why would you want to sleep for 1/10 of a second? Well, let's look at the next logic. We're setting up an infinite loop after that. Well, not an infinite loop, I'm sorry. We're setting up a loop after that. And that loop is basically saying, while my USART 0 over here has something on the line. In other words, while some data is there, we're going to add whatever just came in to our RX data. So these bytes that we've received, as long as there's something there, let's read it and stick it on there. That's what this is saying. And then it's going to come out and it's going to print it out for us. It's going to decode it to UTF-8, which is the universal, it's Unicode 8, basically. So, so this, going back to why do we have a sleeper here? We have a sleeper here because if we were to take what we just got and shot it onto the line, then we're going to miss this next part because it'll get transmitted before we get around to reading it. So if we don't have a sleep there, it's going to send it out and we're going to say, okay, is there anything there? And we're going to be missing it. So that's why we have to put a little sleep in there. So let's go ahead and pull up our code. So here we have our code and we're going to run it. So when we run it, we're going to type in hello world and it gives us back hello world, because what's happened there is hello world came in here. It got written out to the USART 1, my USART 1, slept for a second before it actually started to receive there. And then it got into over here. Actually, I have misspoken. I just realized this. So we did, let's do an experiment here. So it writes it onto the USART, and then it did a sleep. So then we started to collect the data on UART 0. So this sleep, actually, I said that you'd miss it altogether. Let's see what happens. Because I'm going to go in here, I'm going to comment this out, and I'm going to stop this. So if we don't have anything there, and we go ahead and we run it again, and we type in hello world, look, nothing was received. So put it through there and nothing was received. And if I type in again, look what happens. It receives hello world. So what's happening here is we go here, we stall not so that this will get out on the line, but we stall it such that this can start collecting. So it'll put it onto the line, then we can get this thing collecting. So we're giving it a little break there so that it can get everything together and put it onto the wire by the time we get to here. So it puts it on the wire, it starts to put it on the wire, it sleeps so that it can get everything onto the wire, and then we start receiving it here. So they probably fiddled around with this 0.1 number until they got it just to the right speed. They probably did a calculation knowing that, okay, it takes it this long to process it, put it on the line, and then we can start reading it at that point. So this is the entire purpose of that, is to catch the data. So it's going to give it time to actually put it onto the line, and then it's going to start to receive it. Because if we took that out, it missed it the first time because we went straight into the next line of code, but then it caught it on the second one. So yeah, this is just to allow it to get it out on and onto the line. So if we were to stop it now and we were to run it, and we put in, let's say, hello world, this is a long text, it would catch it all in the next line. So that's great. So then we'd say, and then we have another very long text, and you would see that come out that way. So yeah, so anyhow, this is kind of neat. This is just, sending messages back and forth to yourself. It's not terribly exciting in that, but yeah, this is the way that you transmit data. It goes out, you're dealing with bytes here, and bytes are made up of bits, and you're taking a bit and you're sending it over the wire between the different, you're sending it from a transceiver to a receiver, and you can go the opposite way as well. And you just, you kind of build up what you receive in little buckets, and at the end you decode it and print it out. So that's how serial transmission works. So I hope this has been helpful. If you have any question, feel free to reach out and ask me, and I will see you otherwise in the next video. Enjoy.